Yes, sir. Good
Yes,
afternoon.
sir.
Good afternoon. Thank you. Thank you for your response. Okay. So quickly we can get into the session. So here in this class, lastly we can enter into the topic that is actually minimum spanning tree algorithms. Okay. Usually you may be provided one graph. So there you can able to derive such spanning trees. Okay. Can anyone try to say the definition of spanning tree?
Sir, it is a subgraph which includes all the vertices of the original graph.
Very good. That subgraph should be in the form of that subgraph. Your answer is merely correct. 99% is correct. There is one more additional word. That subgraph should be in the shape of tree.
Acyclic.
Very good. Acyclic. That is nothing but tree. Okay. So the we can have one subgraph. Such subgraph should cover all the vertices of the original graph. Furthermore, that subgraph should be in the form of should be in the shape of tree. That means acyclic graph. That should not have any cycles. Okay. So here, if suppose you can just simply imagine like you may be provided one graph like this. Okay, with the weights, age weights 4, maybe 3 or 1 or something like again 4. So here you will have different shapes. So these are spanning tree 1, spanning tree 2. Likewise, you can even derive another spanning tree. Okay, so here, by the way, you can able to determine spanning trees, but so you can even derive like this format also. But here, minimum spanning tree means that involves with respect to the edge weight. Okay, you need to pick which spanning tree is minimum when I add all the edge weights. Okay, if suppose if I say this is a minimum spanning tree means if I add all these three edges, that should be the minimum comparatively with all other spanning tree. So that spanning tree is called minimum spanning tree. Have you understood the definition of minimum spanning tree? Is it clear?
Yes, sir.
Yes, sir.
Okay, fine. So now here, if suppose you may have the graph is provided like 150 or 200 or 300 vertices, there it's very difficult to determine its spanning tree itself. At the same time, we need to consider its minimum also. So that they are following some algorithms. So we are going to just get into the algorithms, how they are following up in the computer codes with respect to some basic examples. So usually they are following minimum spanning tree algorithms means two algorithms. One is Kruskal's algorithm, one more is Prim's algorithm. So we are going to discuss in each method one problems. Okay, so that will be quite easy. So please listen. Okay, so first this problem is given. This graph is given by using Kruskal algorithms. Determine its minimum spanning tree. That is a question will be given to you. Okay, this is very simple question. So usually this kind of questions either Kruskal's or another one is Prim's algorithms. If they focus, if the question comes under minimum spanning tree means that is actually individual questions carries 10 mark. So that can easily complete in 5 minutes. So anyway, please listen. So here if suppose if the question is asked like first your task, you need to remove multiple edges and self loops. That is your task is assigned. If the graph is provided like first you need to remove the self loops and then multiple edges. So here self loop is there for the vertex E, that should be removed first. Okay, next here for the edge AB, I have the multiple edge. One is having either one is having the edge weight as 6, another one is having 9. Can you just try to guess which edge can be removed here? Which edge weight can be removed?
9.
9. Okay, very good. Why you have said 9?
We're finding minimum spanning tree.
Very good. Finding minimum. So that should be the removed. That means 9 should be removed. Okay. So here 9 can be removed. So remaining you can keep 6 as retained. So anyway, So here first your primary task, you need to arrange this in a ascending order. So which is, can you just help me out to say the minimum in the ascending order, like for the edge AE I have 2 weight. Okay, can you try to say the another one? Next, you can say in order, ascending order. Next,
CD3.
very good. CD3. Next,
AC4.
uh, sorry,
AC4.
very good. AC4. Next,
CE4.
CE4. Next,
EB6.
EB6,
BC6.
BC6. Next,
ED7.
ED7. That's it, right? Okay.
Oh, AB also is 6.
Yeah, I think we have missed. What about the another one? EB, sorry. AB is also 6, right?
Yes, sir.
Okay, next.
ED7.
ED7.
Then AD8.
Next, yeah, BD is 8. Okay. So after that,
AD8.
another one is also 8, right? Okay. Okay, AE. AE is also AD or AD, right?
Yes, sir. AD, sir.
Okay, fine. AD is 8. Okay, after that, very simple step. See here, the problem is going to complete. So listen carefully. So it is a spanning tree, right? Spanning tree means that should cover all the vertices. So first I can just draw its outline vertices first, so that it can be easy to me. So this can be in the shape of this. So this is A, B, C, D, E. After that, so now I can go with the ascending order wise. AE. First I can draw AE. So AE. So this should be drawn as a first edge. So that is actually 2. Next, CD. So CD. So next, CD is 3. Next, AC. Okay, next, AC is 4. Next, CE. So if I actually, is there any mistake on the writings, like in the ascending order? Did I miss anything? Everything is correct, correct, right? Okay, fine. So next, if I include CE, listen carefully. If I include CE, that will form a cycle. Can you just guess? A, E, C, E. So I should not include CE edge. Can you understand? Can you understand this step?
Yes, sir.
So because it's a spanning tree, that should not have any cycle. So if I include CU edge on this, so that will form a cycle. So I should not include that. Next, EB. So EB. So that is possibly I can add, right? Okay. So next, BC. Okay. Is it allowed to add BC?
Yes, sir.
Okay. So let me just ask you one thing. Like if I go with like starting from E, A, that means E, A, then, sorry, I'll draw and then. Okay. See here, if I go with A, E, B, C, and then D, will it form a cycle or not? Will it form a cycle or not? That's my question.
Yes, sir.
So if I include BC edge means that will form a cycle. Okay. So whenever you feel like it's a closed means you should not include that edge. Hope you can understand that. So that always you should take a cautious about to include a edge whether it is forming any sort of cycle. If it is so, you should not include that. So here I should not include BC edge. Okay, next AB. Okay, can I include AB edge? Can I include AB edge?
No, sir.
No,
No, sir.
because it will form a cycle like AEBA. So next ED. ED. ED.
No. Yes, sir.
No, sir.
Very good. Next BD.
Yes. No.
Yes
No,
or
sir.
no?
No.
You can't.
No.
You can't.
Very good. Okay,
No,
next.
sir.
Because if I include BD means it may form a cycle like AEBD. So it is again certainly like D to C A. Hope we can understand that, right? Is it right? Okay, next. Last one is AD.
No, sir.
No.
No, that's it. Problem is winded. So now you can just check whether you have got the spanning tree or not.
Yes, sir.
Yes, it covers all the vertices. Also, the length of the, that means what is a minimum spanning tree? That means what is the length of the spanning tree means you need to add all the edge weights. 2 plus 6, 8, 8 plus 4, 12, 12 plus 3, 15. So length of the spanning tree is 15. So here you may raise a question, sir, will it be the exact shape of a spanning tree? Yes, it is true. See here, you should not decide like it is not a, it's a cycle. So here it is just, if you just move away this 3 point some away means you will feel something like it is not connected. It is not connected as a cycle. Okay, so here you need to focus your mind. If you add any edge means that should not create any kind of cycles. Okay, so there are many problems are there, many graphs are provided to determine its minimum spanning tree by using Kruskal's. So you can just try to work out. First you need to arrange all the edge weights in a ascending order. Then with respect to starting lowest value, you can just start verifying it. If it forms a cycle, you can not include that. If it is not forming a cycle means you can include that edge. Finally you can check whether you have got the spanning tree or not. Then if you add that, you should get the minimum value. That is the final answer, 15. Okay, so this is the model Kruskal's algorithm. Okay, next. Okay, with that I'll close. Last problem. See here, same, finding the minimum spanning tree by using Prim's algorithm. That is another method. So it is quite similar, the same format of already you have formed a matrix in your shortest path. The same method only you are going to follow over here. So first let me write the values of it. Okay, so V1, V2, V3, V4, V5, V6. Totally 6 vertices are there, right? Okay, next. So here V1, V2, V3, V4, V5, V6. Okay, after that, so V1 to V1, there is no direct edge, so I can put there dash. Next, it's very simple write-up. So V1 to V2, that is 10. Next, V1 to V3. V1 to V3, that is, can anyone try to help me out quickly? V1 to V3, quickly you can say the all the values.
16.
16. Next, 11. Okay. Next, V5, 10. Next, V6,
Infinity.
V1 to V6.
Dash.
No, V1 to V6. That is a direct edge, right?
Oh, 17.
17. Okay, very good. Next, V2 to V1. 10. Okay. Next, V2 to V2 dash. Next, V2 to V3. 9.5. V2 to V4. There is no direct edge, so I can put there infinity, right? Next, V2 to V5. There is no direct edge, so I can put dash. Next, V2 to V6.
Dash.
Dash.
No,
Dash.
V2 to V6. You can just check properly.
Okay, 19.5. Infinity.
Very correct. 19.5. Next, V3. By fixing V3, so V3 to V1, 16. V3 to V2, that is 9.5. V3 to V4,
7.
Okay. Next, V3 to V4. Sorry. V3 to V3 dash.
Okay.
Sorry. So here V3 to V3, that is dash. V3 to V4, that is 7. V3 to V5, infinity.
Infinity.
Okay. V3 to V6,
12.
Okay. Next, V4 to V1,
11.
11. Okay. V4 to V2,
Infinity.
infinity. Okay. V4 to V3,
7.
V4 to V4 dash. Okay. V4 to V5,
8.
okay. V4 to V6,
7.
okay. Next, V5 to V1,
10.
V5 to V2,
Infinity.
okay. V5 to V3,
Infinity.
okay. V5 to V4, 8.
8.
Right? Okay. V5 to V5 dash. V5 to V6,
9.
9. Okay. Next, V6 to V1, infinity.
17. 17.
17. Okay. Next, V6 to V2, 19.
Oh, 19.5.
Okay. V6 to V3, 12.
12.
V6 to V4,
7.
V6 to V5,
9.
last one is dash. Okay. After that, very simple step. Within 2 minutes, the problem is going to complete. So here you can just draw in the shape of same diagram. So this will be in the shape of V1, V2, V3. V1, V2, V3, V4, V5, V6. So after that, so you can start drawing the minimum spanning tree. You can pick the, see here it's very free rules. You can start from any vertex, not a problem. Okay, but in your shortest path, you need to follow the order with respect to the minimum value. But here, first you are arranged in a well perfect matrix form. Your wish, you can start from any vertex, not a problem. So you will get the same answer. Maybe the diagrams may be different, but final answer minimum value should be unique. So here, my wish, I can start from V1 itself, not a problem. Anyone can try the same diagram, same matrix. You can start from V2 also. You will get the same answer parallelly. Okay. So let me just guide you. Okay. So here I can start from V1. So in V1, what is the lowest value? What is the least value?
10, sir.
10. So I can make a box. So here V1 to V2, that is 10. That was, it shows the value. V1 to V2, that is 10. Okay. After that, so here you may raise the question, sir, there is one more value, V1 to V5, that is also 10. Yes, you are allowed to pick that also. Even if you pick this or this, you will get the same answer. Diagram may be different. Okay. Next. So here you have just traveled V1 to V2, that is 10. Next, I should get into the next row V2, the corresponding value V2. In V2, what is the lowest value?
9.5.
9.5. The corresponding vertex is actually V3. So V2 to V3, that is 9.5. V2 to V3, that is 9.5. Next, I should get into the vertex V3 row. So in V3 row, what is the least value? 7. So V3 to V4, 7. V3 to V4, 7. Next. So now I should get into the fourth row. So in V4, what is the least value?
7.
So if I make box, so V4 to V3. Okay, you can just check. V4 to V3. Already you have created a 7. So you have stopped the process. Still, there is a pending vertices to cover. So now I could not even say this as a spanning tree. So I should check the row properly. Is there any other possibility of minimum value?
Another 7 as well.
Another 7. Very good. So instead of picking this, I should pick this box. Okay, I hope you can understand. In one way, you will get stuck. You could not draw the completion of the spanning tree. In that manner, you should check the row properly. Is there any other values are being the same value, least value? In that manner, you need to pick the another pair like V4 to V6 as 7. So V4 to V6 as 7. So here that is 7. Next. So next, which row I need to check?
V5.
No. Which row I need to check?
V6.
V6. Very good. So in V6, what is the least value?
7.
7. So that is actually V6 to V4. Okay. So that is repeated. So next, there is one more pending vertex is there. That is actually fifth one, right? So in fifth, in that case only you need to get into listen carefully. If suppose if there is one pending vertex is uncovered, in that manner only you are supposed to get into that particular vertex row. So now if we could see V5 row, what is the least value?
8.
8. So V5 to V4 is actually 8. So here V5 to V4, that value is actually 8. So I can include that 8. Next. So now you have covered all the vertex rows, right? At the same time, you have just created one spanning tree. So now, can you just accept this as a spanning tree? Yes or no? Yes or no?
Yes.
Is it yes? So now, if you could add all the edge weights, that will be the final answer. What is the length of this spanning tree? What is the length of this spanning tree?
41.5.
41.5. That is the exact answer. You may just have doubted like, sir, if suppose instead of this vertex, if you have chosen like V1 to V5 as 10 means, certainly you will get the same length, but diagram is not needed to be unique. You can just check instead V1 to V2 as 10. If you have chosen like V1 to V5 as 10 means, in that case, V1 to V5 as 10, this edge will be gone out because this will form a cycle. So this certainly would not be included. So this will be in the shape of like in that manner you will have that. Okay, but this is also forms a spanning tree. This will attain the minimum length. That means same 41.5 only you will attain the answer. Can you understand what I have said on this? Can you get the point?
Yes, sir.
Yes.
See here, that's what I have already told you clearly. Your wish, you can start from any vertex. That's your wish. Finally, your graph may not be unique, but your length of the spanning tree should be same for everyone, whoever may start from another vertex. So that's what I have clearly told. You can start from any vertex. So final answer should be as 41.5. So that's the method of finding the minimum spanning tree by using algorithms in two ways. One is Kruskal, another one is Prim's. In Kruskal's, you should have followed like writing the edge weights in ascending order. Then you can just strike if the word edge forms a cycle. Otherwise, you can just continue the process until the last edge. In your Prim's algorithm, first you need to convert, you need to create a matrix representation between every pair of the vertices. Finally, with respect to any vertex chosen, you can start adding the edge. Finally, you will attain the minimum spanning tree and its length. So that's a method on both the topic. Is it clear?
So,
Yes.
so can you please explain the in V4 why we shouldn't take the first 7 one, the
Yes.
minimum?
That means this part, right?
Yes.
Okay. See here, in V4 to See, just let me explain from the V3 itself, because in V3, what we have chosen V3 to V4 as 7. Okay, V3 to V4 as 7. So just you can just consider like 7 and then 8 currently not added. Okay, you can just draw the diagram up to V4. So that means V3 to V4 you are added from the V3 row by adding 7 edge weight. Okay, next I should get into the V4th row. If I get into the 4th row, the value I have picked like 7. If I box it like 7 means that is actually V4 to V3. So that was already created edge. Already you have created V4 to V3 as 7. So still I am getting like round wise, like I am repeated in the edges. So in that case, if I am getting any repetition in the edges, I need to take a look on the particular row. Is there any equivalent edge weight is there on the same particular row? See here in your V4th row, I have another value with the same 7. So I can pick another pair. Instead of picking V4 to V3, I have chosen V4 to V6. That edge is not yet created. So now we are going to create this edge, that is V4 to V6 as 7. That is the reason we have chosen that another edge. Is it clear?
Yes, sir. So if instead of 7 there was something else, then we should just leave it like
Yeah,
there.
exactly right. Exactly, you're right. In that case, a very good question. In that case, you need to get into the previous, if suppose, anyway, good question. So here instead 7, you might have like 9 or something. Like in that case, I need to take a look on the any other equivalent values. Like in V1, I have the possibility of picking V1 to V2 or V1 to V5, right? So in that case, I need to check for V1 to V5. So by the way, I can just check with the preceding vertex rows. You will automatically get the idea. You can just try to solve the problems from your textbook or any other internet sources also. You will get the idea. By solving the graphs, you will automatically get the idea how they are determining the spanning tree, how it can be decided as minimum. Okay?
Okay. Got it,
Okay.
sir. Thank you, sir.
Yes. Thank you.